Today we want to continue our look at ellipses. Now, I first want to start off by reviewing kind of what we have done previously with ellipses. We talked about the definition, the sum of all points where the sum of the distance from the foci is constant. We looked at our equations of an ellipse, and some of the highlights here where a is always the larger of the two numbers, and our c squared is equal to a squared minus b squared. We had our center HK, and then our vertices and foci we found by adding and subtracting A or C, depending if our ellipse was opening kind of left and right or whether it was opening up or down. We looked at examples where we'd find our center. We'd go whatever was underneath the X, which in this case is 25, so our A is 5. So we would go right and left 5. We'd look what's underneath the Y, which was 9, so our B was 3. So we go up and down 3. And then that would give us our center and our vertices, which are at the end of A. And if you remember, we also called these two things from vertice to vertice was known as our major axis. That was the longer of the two, that was 2A. And then we had our minor axis, which was 2B, that went like that. We then could find our C with c squared minus b squared minus a squared. In this case, it was 4, and we put in X where our foci were. In this example, it was longer left and right. If we looked at an example where the A was underneath the Y, the bigger numbers underneath the Y, this is our major axis is now up and down, and it's kind of opening up and down. That's kind of what we looked at previously. We did an example, we were given some information, and we wanted to try to find our equation. That's what we want to really look at here today. So let's look at an example. Find the equation of an ellipse that has a vertice at -3, 2 and 5, 2, and it has a major axis of length 6. So step 1 is let's draw a picture. So we're just going to make a rough picture of this to give us some idea what's going on. We have a vertice at 5, 2. There's our one vertice. And -3, 2 is our other vertice. That tells us that our center is at 1, 2. So similar to the one we looked at last week, but a little different. Okay, so it's at 1, 2. Now, that's going to tell us right away what our A is. If you remember, the length of this major axis is 2A, and so our A is just that distance from the center to the vertice, which is 1, 2, 3, 4. So that is our 4. Now, to find our equation, the other thing we need to find is B. Well, we can get B from the length of our minor axis is 6. That tells us from our center, we are going to go up 3, and we're going to go down 3, which tells us our B is 3. Now, we could connect those dots if we were trying to graph this ellipse. All we want to do is find the equation. So that tells us it's going to be x minus 1 squared plus y minus 2 squared. Remember, ellipses are always equal to 1. This is our vertices are here. So our A goes under our x, and our A squared goes in the formula. So that's 16. And then B squared is 9. So there is our formula. So what we're going to look at today is kind of going backwards. Last week we looked at given the equation to find the center and the foci and the vertices and come up with the equation. Here we want to kind of go the other way. Given information, let's find the equation. And the key to all of these is drawing a picture. So another one. So we want to kind of do a rough sketch at 1, 3. 1, 2, 3 is a foci. And at 1, -3 is the other foci. That's going to tell us our center is right in the middle, and our center is the point 1, 0. Now remember, to find the equation, what we need to know is we need to know our center, we need to know A, and we need to know B. Now, it also tells us that at 1, -6, 1, 4, 5, 6, is one of our vertices. So this tells us right here, this is our center here, not C, excuse me, that this is C is 3. Since this is a vertice, that tells us that this distance A is 6. So what we need to do is find B. And our formula for an ellipse is C squared equals A squared minus B squared. So that is 3 squared is 6 squared minus B squared. That is 9 equals 36 minus B squared, which would be B squared is 36 minus 9. So B squared equals 27. And really, you notice that's B squared. I really don't even need to know B. I really need to know B squared. So now my equation will be x minus 1 squared plus y squared equals 1. And the next thing I have to determine is where does the A go, under the x or the y? Well, if we look here, this opens up or down. Our major axis is up or down. That means our A goes here. So A squared is 36, and I wrote this here. Our B is the square root of 27, or B squared is just 27. Really, to find your equation, you don't have to find A or B. You just have to find A squared and B squared. Now, the other thing we're going to look at today is what happens if we're given something in this form. It is not in our standard form that we can easily see our center and our A and our B. We want to put it into that form. So, if you remember completing the squares, we're going to have to now complete the square with both the x's and the y's. So what we're going to do is we are going to take all the x's, put them in parentheses. I'm leaving space to add something. Then we're going to take our y's, put them in parentheses. And then I'm going to take all the numbers, in this case it's just 1, and I'm going to throw it to the other side. Now, before we can complete the square, you see on the y's here, we're going to have to factor out the 2. So if I factor out the 2, I get to there. Because in order to complete the square, I can only have a 1 in front of the y or the x. So here, half the middle term squared is plus 1. So I'm going to add 1 over here. Here, half the middle term squared is plus 1. But remember, I've actually added 2 times 1. So I've actually added 2. So I have to add 2 over here. That's going to then factor into x minus 1 squared plus 2 y plus 1 squared equals 2. And the final thing, as we said, ellipses always, always, always have to equal 1. So I'm going to have to divide by 2 to get 1. So if I divide everything by 2, I am going to get x minus 1 squared over 2 plus, these cancel, y plus 1 squared over 1. So there's our formula, and we can see from here that our center is 1, -1. Now, to find our foci, I need to know my A, B, and C. So over here, I can determine my A is the square root of 2. My B is 1. So my C squared is A squared minus B squared, which is going to be 1. So C is 1. You can see that our A is underneath the X. That means I'm going to be moving left and right for my foci. So this is 1 plus or minus 1 negative 1. Now that last part we did pretty quick. That goes back to what we did to start last time on how we find our foci and center from the equation. So here we had to complete the square with the y's. But the x's, since there was a 1 in front of the x squared, we didn't need to factor anything for the x's. But let's look at an example where we have to factor out of both. And I'm going to kind of do this in an extra step here. If we look at our y's and our x's, I'm going to kind of factor them in one step. With the x's, I can take out a 3, and I get x squared plus 4x. For the y's, I can take out a 4, and I get y squared minus 2y. And I'm going to take the 32, and I'm going to put it on the other side. Next, we complete the square. Half of 4 squared is 4, but I actually added 3 times 4, so I need to add 12. Half of 2 squared is 1, so I add 1, but I've actually added 4, so that's plus 4. So this gives me 3x plus 2 squared plus 4y minus 1 squared. And this is 32. This is going to give me 48. And as we said before, they always have to equal 1. So 48 is 1. Divide by 48. Divide by 48. This is going to give us x plus 2 squared is 16 plus y minus 1 squared is 12. Now, if we want to find our center is -2, 1. And our foci, we want to figure out where is the A. The A is underneath the X. So that's going to tell me I am going to add and subtract my C to the X. But I got to find C. So C squared is equal to A squared minus B squared. So that tells me C squared is 4. So C is 2. So I put add and subtract 2. If we wanted to, it doesn't ask for it here, but just so we understand, right? If we wanted to find our vertices, we would do the same thing, but we would add and subtract A. And our A is 4, A squared 16. So I would add and subtract 4 right there. The last thing we want to look at today is an application of these ellipses. And I talked about these in class, but we actually want to look at an example. And that has to do with the planetary orbits. And they kind of give us a little bit of some guidance here on how this is going to work. But if you look at this diagram over here to the right, if a planet is orbiting around the sun, now we're doing this with the center of our ellipse at 0, 0. The sun is at 1 foci. The other foci would be kind of out here in space, but we're not going to really consider that one here for what we're doing today. And we have these two distances, and I'll try to say these right. I think it's the perihelion and the aphelion. And what these are is the distance from the sun at the foci to this point. That's basically the closest the planet ever is to the sun. And then the alpha helium is this point over here where the planet is as far away as possible from the sun. Now, as you look at that total distance between those 2 points, that's just our major axis. So that total distance there between those 2 points is just going to be 2a. And they give us that formula up here, that 2a is these two things being added together. So we want to do that for Mars. So for Mars, we can say, well, 2a is equal to, and here is Mars right here. So 2a is going to be 128.49 plus 154.83. So we add those up, we divide by 2, and we get A as 141.66. Now, we then need to find B to find our equation. So we're going to use this formula right here. Okay. So notice we got to find our C by this formula here first, which in this case, C is going to be 141.66 minus the perihelium, which is 128.49, which gives me 13.17. And then finally, to find my B, I know B squared is equal to my A squared minus my C squared, and they're just giving us these formulas here. And if I do that, I get my B to be 141.05. Now, notice for Mars, the one that we're doing, these A and B are actually very close and very similar. That tells us, remember, that our foci are both very close to the center. That tells us our orbit is very close to a circle. And if you look at some of these other planets, you will notice, Venus, very close, Earth, very close to the same. Those are closer to the circle. Something like Mercury is much further. These two distances are much different. That's going to give us very different answers. So finally, we want to write our equation. Now these are centered at the origin, remember, and our A is underneath our X. So we get X squared over 141.66 squared plus Y squared over 141.05 squared equals 1. And if I write these down by actually squaring those numbers, I get 20067.56 plus Y squared over 19895.10. So you can see we now have a formula for the ellipse that is the orbit of Mars around the sun. So if we wanted to predict where Mars is at a specific spot, we could now use this formula to help us calculate that. Now, remember, once you've watched the video and taken the notes, make sure you click to complete the lesson in Otis so that you can get credit for having looked at the video and having completed it and get the points for that. The homework from this is a worksheet that's on Otis that can be completed, and then upload the picture of that in the assessments.